A development laboratory or a Devlab is an environment designed to support software development. In a Devlab, you can use such services as the automated creation and purging of development containers on the fly, automated testing, DevOps pipelines, source code management, load testing, application vulnerability scanning, and similar. A Devlab can use similar infrastructure to what might be used in a production environment. However, there are differences in the ways of using the infrastructure that require special handling in a Devlab. In a production environment, the services are installed and operated, then updated when a new version of the code is released. In a Devlab, a developer might run the same code in multiple environments, for example, in Debian, Fedora, and Windows, or even multiple versions of the same code in multiple environments. Besides, a developer might need to recreate the same environment multiple times per day, and this requires a different type of infrastructure management and administration. Many of the services that a developer requires are not used by the end users. A quick example is the testing platform. And there is also a difference in the security model because source code security is completely different from the security of the service that the code serves. Even when the code is free and open source, the end users do not have right access to the code or the infrastructure that runs the development of the software. Users only have access to their own version of the software running in their own infrastructure. I run my personal Devlab at home, but I would not consider it a typical home lab. Based on what I see and read, home labs usually run production releases of software, which would qualify them as production environments. Home labs include lots of Docker instances, and it seems to me that Docker is the preferred platform for running services in a home lab. In my Devlab, I run tens of LXC containers and kernel VMs, but only one of them includes Docker. It is the container that runs my DevOps pipelines. I am not against using Docker for hosting production services. However, because Docker images are immutable, it is very difficult to change anything in them, and it is a lot easier to build the software and change it as needed in LXC containers. Basically, I view Docker containers as release artifacts, not development tools. They are more suitable for production environments, while LXC containers are more suitable for development. In this series, we will set up and configure scenarios where both labs, a dev lab and a home lab, coexist on the same hardware. We will start by building our own DevLab virtualization environment. Then we will create all types of automations. For example, we will create automations for web development environment for things like WordPress or Drupal, for Java development, and even for AI development, for mobile development. We will have also pipelines for automated testing and for continuous integration and continuous deployment and much, much more. Now let's see what we need. We can use any type 1 hypervisor to host our Devlab. Options like Red Hat Enterprise Linux, Fedora Linux, Debian Linux, Proxmox Virtual Environment, and Windows Server, and VMware ESXi, and many others are all valid options for the Devlab. And we will explore many of them later in this series. Choosing an option is a highly opinionated decision. Some people may choose a certain platform because they know it, and others may choose a certain platform because they want to learn it. I understand that this choice is always subjective, and that's why I will not run a comparison between the options. I have selected to start with Proxmox Virtual Environment PVE as my first Devlab experiment, and I will run it inside my main Devlab, which is also a PVE, a Proxmox Virtual Environment. To avoid confusion, I will call them the main PVE for my original Devlab and the Devlab PVE for the Devlab BVE that I will run in this series. A Devlab is not a stable environment. Many things can break during development, which would require rebuilding. A good Devlab design would assume that the entire lab would break at a certain time and design automation pipelines to rebuild everything. The current paradigm for achieving this type of design is called infrastructure as code, or IAC. The leading IAC tool as I see it right now is Terraform, which is a great tool to manage stable, immutable environment. Terraform saves the current running infrastructure state as code and then manages changes to that infrastructure when the code changes. In a mutable environment like a Devlab, where infrastructure is created and disposed on the fly multiple times, Terraform can be an overhead, because a Devlab's environment state is irrelevant in most cases. I find Ansible more suitable for the job. Ansible does not worry about the current state of the environment as a whole. It focuses on implementing changes to the environment in a generic way. Ansible is a Python-based technology. It is a popular infrastructure as code tool and in the enterprise space. This series assumes that the reader is familiar with Ansible. So here are some references and tutorials to get you started. Links will be in the article. The article links will be in the description of the video. We have first the Ansible documentation, which has a page called Getting Started with Ansible. There is also an Ansible 101, which is a series of video streams by Jeff Gerling. And I'll also link to a series called Getting Started with Ansible. That's a video series by Learn Linux TV on YouTube. Although this Devlab series is not designed for beginners, it will be very easy for people who know Ansible basics only, and can be considered as an applied course in automation with Ansible. In this series, we will develop our own automation tools, and for this we need a development environment for developing automations. I will use VS Codium as my IDE, and I will add the following extensions to it. Open Remote SSH extension. This extension allows opening a remote development server on a remote host, and it allows you to work on the remote host as if you are working on your machine. Then we will add the Ansible extension, which is the official Ansible extension for VS Codium. In a good Devlab design, the IDE can run on any physical machine, but the actual development work should be independent from that machine. The developer should access their development projects from any machine. To achieve this goal, we will design our Devlab to use virtual development environment. The first development machine that we will need is an Ansible controller. That is where Ansible roles and playbooks are developed, tested, and executed to create our Devlab. The Ansible controller can be the same machine that runs the IDE, or a virtual machine or a virtual environment inside it or outside it. I will start with a static LXC container as my Ansible controller. This will be based on the official Debian container template, and it will run inside my main BVE, which will host the new Devlab for the series. Later on, the development environment will become more dynamic when the Devlab is operational. Now let's prepare an Ansible controller for our Devlab. On the left side of the screen, I have an install of Proxmox that has two containers. One is a supposed Ansible controller based on Debian, and the other one is an Ansible controller based on Fedora. On the right side of the screen, I'm logged into my Ansible controller, and I will run a playbook that includes the two roles that we will create in the next episode of this series. This playbook will completely remove both containers and recreate them again. So now the Ansible controller based on Debian is ready, and I can log in with the root password. And I can issue the command for preparing the Ansible controller based on Debian. This command will be in the article, and the article link will be in the description of this video. While this is running, I can work on the Fedora container and log in with the root password. And for Fedora, I need to copy the script from the article, and this script will first upgrade all dependencies in Fedora, then we'll install Python 3. It's already installed, but Ansible, I make sure it's installed, Ansible and Open SSH server. This is important because the Fedora container comes with SSH client. It does not come with SSH server, so we need to install it and then enable it. Then we create a Devlab code directory, we cd into that directory, and we create a Python virtual environment in that directory. Then we activate that Python virtual environment and we install the Python dependencies, which are cryptography, librouter OS, Proxmoxer, and requests. Then we enable the SSH server so that we can log into this container from any other container in our Devlab. So the install is progressing now. It will soon be over. Great. So now you see we are still in our virtual environment, and I think we have Ansible ready now. Yes. So let's install the requirement. We create a requirements.yaml file, and the contents are available in the article. So I will copy paste them here and save the file and run the command from the article. This will install the Ansible Galaxy collections that we will need in the first few episodes of this series. We need to do the same thing in Debian. So let's go to Debian and so now we bring the command. And when this is finished, we will have two working Ansible controllers. One is on Debian and one on Fedora. In the next episode of the series, we will create the two roles that you have seen in action here. After that, we will create two routers, one router based on Debian and one router based on Router OS, and then we will start automating our Devlab. So follow up the series and talk to you later.